In high-volume outbound email systems, reputation is not incidental. It is accumulated, evaluated, and enforced continuously. Dedicated IP pools are not a scaling convenience, they are a control mechanism. In this walkthrough, we will examine how IP pool design determines delivery stability. At high volume, outbound email infrastructure behaves as a distributed system with cumulative state. Every message passes through structured control layers before reaching a mailbox provider. The sending platform defines payload and metadata. The relay layer enforces concurrency limits and retry logic. A policy engine determines how traffic is routed and classified. IP pools accumulate behavioral history over time. Mailbox providers evaluate patterns, not isolated messages. Instability in one layer propagates across the entire system. Without dedicated IP pools, traffic with different behavioral profiles converges into shared reputation space. Cold outreach often carries higher variance in engagement and complaint behavior. Bulk traffic may exhibit stable historical patterns. Mailbox providers do not differentiate between traffic categories. They evaluate the aggregated behavior of the sending IP. When signals merge, instability propagates across all traffic routed through that pool. The architecture itself creates contamination. The impact of shared IP space becomes visible through deferral behavior. In a dedicated bulk-only pool, 4xx rates typically remain within predictable limits. When cold traffic is introduced into the same IP space, behavioral variance increases. Mailbox providers respond gradually. Temporary deferrals escalate. Throughput decreases before any outright blocking occurs. The system begins to lose stability progressively. Temporary deferrals do not disappear. They trigger structured retry cycles. Each rejected message re-enters the queue. In a dedicated IP environment, queue depth fluctuates within predictable operational limits. Under shared IP conditions, backlog accumulates progressively, retry pressure increases, delivery latency extends. The system transitions from throughput control to backlog management. Bounce classification directly influences reputation control. In a dedicated IP environment, signal interpretation remains isolated. Cold traffic errors do not affect bulk suppression logic. Under shared IP conditions, transient 4xx deferrals and hard bounces become harder to distinguish. Suppression mechanisms may overreact. Complaint ratios appear elevated due to reduced delivered volume. The infrastructure begins making corrective decisions based on distorted signals. At this stage, instability is no longer external, it is systemic. Traffic isolation must occur at the policy layer, not at the IP layer alone. The sending platform defines message attributes. The relay layer manages throughput. The policy engine classifies traffic according to behavioral profile and lifecycle stage. Cold outreach and established bulk traffic are routed through separate control paths. Each path maps to an independent IP pool. Reputation accumulation remains isolated by design. Architectural separation prevents cross-pool contamination. A dedicated IP pool is not merely a separate address range. It is a controlled behavioral environment. Cold IP pools operate under strict ramp schedules. Concurrency is capped. Volume increases are gradual and monitored closely. Bulk IP pools, by contrast, assume established engagement history. Throughput is stable. Complaint thresholds are tightly enforced. The two environments follow different tolerance models and different lifecycle expectations. Reputation control depends on preserving these behavioral boundaries. Dedicated IP pools require domain-aware rate shaping. Mailbox providers implement different behavioral models. Gmail reacts dynamically to engagement and short-term anomalies. Concurrency and rate caps must adapt in near real time. Outlook tends to enforce structured throttling and grey listing patterns. Retry timing becomes critical. Smaller providers often require conservative scaling and predictable throughput. Without ISP-aware routing, even dedicated IP pools can accumulate instability. Reputation control therefore extends beyond IP allocation into domain-specific policy enforcement. Reputation stability must be measured through operational signals, not commercial metrics. Deferral rate trends provide early warning of domain-specific stress. Acceleration patterns often precede larger disruption. Bounce classification must remain precise. Misinterpretation distorts suppression logic and reputation state. Complaint signals represent direct negative feedback from mailbox providers. Threshold breaches require immediate routing adjustment. Internally, queue depth and retry behavior reveal whether the system is under pressure. Monitoring must be continuous, segmented, and domain-aware. Stability is verified, not assumed. High-volume outbound email infrastructure behaves as a stateful system. Reputation accumulates across IP space and across time. When traffic with different behavioral variants shares infrastructure, instability propagates. Dedicated IP pools establish clear behavioral boundaries. Domain-aware routing enforces adaptive control. Lifecycle management protects long-term reputation state. Stability is not a feature, it is the result of deliberate architectural design.